All right, so this is the crescendo of chapter 20 where we're synthesizing everything. And this is the second example on page 15 where we're trying to synthesize this ketone from alcohols of 4 carbons or less. So a good way to always start these ones out is just to number or to count our carbon skeleton and say, oh, is there an easy way to break this up? And if we look at what we have here, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. So we have 8 carbons. We have to assume that they're going to break down into units of 4 and 4, most likely. So if we look at units of 4 and 4, we have 1, 2, 3, 4 carbons there, and 1, 2, 3, 4 carbons there. So let's just start by numbering those carbon units. So 1, 2, 3, 4, and then we'll do 5, 6, 7, and 8. We must have been making a connection between the 4 carbon units. So I'm going to draw a little disconnection sign right there and say, oh, well, how would we have made that? We must have, since the carbonyl is here, we have to assume that this side is probably the electrophilic component, so we'll put a partial positive there. And this has to be the nucleophilic component, so partial minus there. Nucleophiles are negatively charged. So bringing that back, we have to assume that we're probably going to have this unit as an organolithiate or Grignard reagent. So let's draw that 4 carbon piece as a lithiate. And just to be very clear about that, I'll do 1, 2, 3, and 4 along there to say those 4 carbons are part of the lithiate. And then in this chapter, we know how to add organolithiates to Grignards, to a lot of different things. But if we add it to an ester, a carboxylic acid, an amide, a acid chloride, we can't stop at a single addition with the acid chloride or the ester. It adds multiple times, and we don't want that to happen. And we can't add them to the carboxylic acid or the amide because that will lead to just a deprotonation. So we have to be adding this to the aldehyde. That's the only way that we can just add a single equivalent of this. So if we have the aldehyde of that product ketone, so if we add these together, so we'll do number 1, and we'll put this in diethyl ether, that is going to add to that carbon right there, and it's going to result in an alkoxide. And alkoxide is the O-. So we have to reprotonate that. So 2, we're going to add H3O+. So with those 2 reagents, the product of these steps, so actually take a minute and draw what the product of those 2 steps are. You're going to see that it's not the product up here. So do that right now. Boop, boop, boop. All right, you did it. And you saw that the product of these 2 steps was actually the alcohol here. But the alcohol here is not the desired ketone product, so we have to ask ourselves, well, how do we get from the alcohol to the ketone? And to do that, we have to oxidize it. So again, we can use PCC in dichloromethane as our solvent. That is going to get us to our product. So how do we get to here, though? Because this is kind of the disconnection that we can say we need to do, but we have to get there from 4 alcohols of 4 carbons or less. So this is an aldehyde, not an alcohol, so we have to take an alcohol. So we can take an alcohol that looks just like that, and we can convert it. And again, this has 1, 2, 3, 4 carbons, and we can look at where they are over here and say this is carbon 5, 6, 7, and 8, and we're just converting that to the ketone or to the aldehyde. So we're going to use PCC in dichloromethane. And sometimes I write DCM for dichloromethane. Sometimes I write CH2Cl2. This is dichloromethane, so I just wanted to write both of those up there. Okay, so that's how we got that. We also need to get this organolithiate. We can't just start with that. We have to get that from the alcohol. So if we have an alcohol like this, we know that the lithiate end product, this lithiate here, has to be accessed from the alkyl halide. So there has to be a halogen in this position. So we're going to do bromine as our halogen, and we're just adding lithium metal in an inert solvent, so diethyl ether. And that is going to form the lithiate from our alkyl bromide. And how do we get our alkyl bromide? One way would just be to add HBr to this alcohol. Another way is that specialty reagent that we talked about, PBr3, that forces a SN2 reaction of the alcohol with the bromide to form our bromide product. So we started with a 4-carbon alcohol unit here, which results in carbons 1 through 4 of the product. We started with this 4-carbon alcohol here. It results in 5, 6, 7, and 8 of the product. That's how we do it. That's how we make that product from alcohols of 4 carbons or less.